The focus of this video will be on working with percents in various ways. To that end, we're going to focus on 5 things. First, converting a decimal to a percent. Second, finding the percent of a value. Third, using percents for discounts. Fourth, using percents for markups. And fifth, doing all of these together in one problem. We'll start with converting a decimal to a percent. Remember that the whole version of a decimal is 1.00. That represents one whole, W-H-O-L-E. But one whole in percent is represented by 100, because 100% means all of something. And in decimal form, 1.00 means all of something, one full unit. So in order for us to convert from a decimal to a percent, we need to move our decimal 2 places to the right, because 1.00 in decimal is equivalent to 100 if we're looking at it in percent form. So if I've got decimal form 1.00, in order to translate it into a percent, I'm just going to grab that dot, move it over 2 places, and now my number becomes 100, and the decimal would be at the end. When we have a decimal at the end with no numbers following it, we can leave it blank, just like we have here 100 as the percent. Let's look at our next one. Decimal form says 0.5. I'm going to do the same thing. I'm going to grab that decimal and move it over 2 places to the right. When I move that decimal, notice that I don't have a second number in this space. I've got a 5 and a blank space. When you have a blank space to the right because you've moved your decimal past where your numbers ended, you need to drop in a 0 to fill in that empty space. So my percent form now is 50%. Same thing again, 0.64. I'm going to grab that decimal, move it over 2. So now I have 64.0, which I can drop out, so it's just 64%. Third one, 0.095. I'm going to grab that decimal, move it over past the second 0, past the 9, and drop it between the 9 and the 5. So now I have 9.5%. This last one, I've got 2.08. I'm going to grab that decimal, move it 2 to the right, and I end up with 208%. Now let's reverse it and go from percent form to decimal form. When I have things in percent form and I want to change them to decimals, I need to grab that decimal and move it 2 to the left. So if I have 100% and I want to change it to decimal, I'm going to grab where the decimal would be, which is after the second 0 of 100, and move it 2 to the left so it falls between the 1 and the first 0. So my decimal form is 1.00. We already know that from our example a moment ago. Let's try this with 75%. Grab the decimal from where it exists after the 5 and move it over 2 to the left. We get 0.75 or 0.75 as our decimal form. Notice when I write the decimal form, I'm not putting percent signs after them because these aren't percents. They're being represented as decimals. Let's look at our third one, 16%. Grab where that decimal should be after the 6, move it 2 to the left, between the 1 and the 6, then in front of the 1, we get 0.16 or 0.16. Next one, 4%. Grab that decimal, move it 2 to the left, drop it in. Now notice here I've got a blank spot between my decimal and my 4. I've got to fill in that missing 0 there. When we've got a blank space moving to the left, just like when we moved the dot to the right, it gets filled in with a 0. So I now have the decimal form of 0.04 or 0.04. Last one, 358%. Grab that decimal from the end, move it 2 to the left, drop it between the 3 and the 5. Our decimal form is now 3.58. Now let's move on to finding the percent of a numeric value. Keep in mind that 100% represents one whole of something. Therefore, if I say I have 100% of 25, that means I have 25, because I'm saying I have all of that 25. If I say I have 50% of 25, I'm saying I have half of a whole, because 50 is half of 100, and 100 represents the whole in percent. Therefore, 50% of 25 is the same as 25 divided by 2, which is equal to 12.5. So 50% of 25 is 12.5. How about 10% of 25? Well, if 100% is one whole, 10% of that would be 1/10. So I can take my 25 and divide it by 10. In this case, I get 10% of 25 equals 2.5. But there's another way we can think about this, and it'll be more useful when we're using percentages that aren't even like these, such as when we want to know 7% of something or 17.5% of something. Our alternative has two steps. The first step is to convert the percent to a decimal. The second step is to multiply that decimal by the value or the number. So let's start with each of these three examples and convert them first to decimals. When I move my decimals 2 to the left for each of the percentages, I get 1.00, 0.50, and 0.10. Now I need to multiply those by the number 25, because that's what my question is asking me to do, find portions of 25. Finally, find the product of the multiplication. 1.00 times 25 gives us 25. 0.50 times 25 gives us 12.5. And 0.10 times 25 gives us 2.5. These are the same answers we found using the fraction version, but this method of using the two-step process will make things a lot easier when, again, we have more complex questions. Let's try a few now. Pause here and try each of the following. Find 5% of 16, 117% of 200, 60% of 45, 250% of 3, and 0.9% of 80. First, I converted my percents to decimals by moving the decimal place 2 to the left. Then, I multiplied those by the values indicated. The products I yielded in order are 0.8, 234, 27, 7.5, and 0.72. Before we move on, let's take a look back at these answers and make sure they make sense. In the first one, we're asking for 5% of 16. 5% is a very small portion of something, and 16 is a fairly small number. So I'm getting a small portion of something that's small, so I should have a pretty small result, and I do, 0.8. On the next one, I'm asking for 117 of 200. 117% is a large portion. 200 is a fairly large number, so I should have a fairly large number as a result. And it should be greater than 200 because 117% means more than all of 200. And I have a result of 234 that meets those criteria. For the next one, I'm asking for 60% of 45. That's a little bit more than half of 45. So I'm expecting my number to be over about 22.5, but below around a 30. And I have an answer of 27. The next one is asking me for 250% of 3. That means I want 2.5 times whatever 3 is, right? Because each 100% is a complete 3. So I've got 2 complete 3s and a half of a 3. Because 200% would be double 3, and 50% would be another half of 3. And that is what I get, 7.5. That's a 3 plus a 3 plus a half of a 3. This last one, we're asking for 0.9% of 80. That 0.9% is a really small portion, a little bit less than 1%. And our number 80 is moderately large. So because I'm taking a really small portion of a moderate number, I'm expecting a fairly small result. And we have one, 0.72. So the answers we're yielding are making sense. If you get a number that looks peculiar, like if we've multiplied a small percentage by a small number and we get a really big result, that should clue you in that you've made a mistake somewhere, such as you forgot to move your decimals over in step 1 before multiplying. Now we're ready to look at discounts using percents. Remember that 100% represents one whole. So if I pay 100% of a price, it means I paid the full price. If I paid 50% of the price, which is half of 100, it means I paid half of the full price. Let's try some examples. Let's say the item I want to purchase costs $100, but they're offering it at 20% off. I have a couple of ways I can figure out what the price I'm going to pay is. I can either figure out what 20% of 100 is and deduct it from 100, or I can figure out what portion of 100 I'm going to pay as a percentage and multiply. We'll do each of these versions. Let's start with finding what 20% of 100 is. We first need to convert our percentage to a decimal, and then we'll multiply that decimal version by the price. The decimal version of 20% is 0.20. I then want to multiply that by the full price of $100. If I plug this into my calculator, or you can do it in your head, I get that 0.20 of $100 is $20. This means my discount is $20 off the original price. The original price was $100, so I'll take $100, subtract the $20, and my purchase price before tax is going to be $80. So the discounted price when on a $100 item is 20% off is $80. But my second option is to find what percentage of the price I'm going to pay after the discount and then multiply that percentage in decimal form by the price. If I'm getting 20% off of an item and 100% represents the full price, what price or what percentage of the price will I be paying? 100% minus 20% equals 80%. So that means when I get 20% off of a price, I'm only paying 80% of the original price. Now let's convert that 80% to decimal form. I'm going to take my 80%, grab my decimal, move it over 2 to the left, and I get that my decimal version is 0.80. Multiply that by the original price. I'm going to pay 0.80 of $100. If I put that into my calculator, or you can do it in your head, I get that my purchase price is going to be $80. Notice that I have two different methods here, but they're yielding the same result. I can either find how much to remove from the full price, that is what's my discount percent equal to in dollars, and subtract it, or I can find what percentage of the whole price I'll be paying and multiply that by the whole price. Either of these options are viable. It's really up to you which one you prefer to use. Pause here and try each of these examples. When the price is $15, but you get 10% off. When the price is $6, but you get 40% off. And when the price is $878 and you get 22% off. For each of these, pause and find what the price is you'll pay after the discount. We have two options, so I'll show them both to you. The first step for either one is to convert the percentage into a decimal. I can either convert the percentage off to a decimal, so 10% becomes 0.10, 40% becomes 0.40, and 22% becomes 0.22, or I can find what percentage I'll pay and then convert that. On the first one, if I get 10% off, that means I'm going to pay 90%, or 0.90 in decimal form. In the second one, if I get 40% off, that means I'm going to pay 60%, or 0.60 in decimal form. And the last one, if I get 22% off, I'm going to pay 78%, or 0.78 in decimal form. Now we can multiply by the price. Let me start with when I found how much to deduct, and then I'll subtract it from the price. When I get 10% off of $15, 10% of $15 equals 1.50. Then I need to subtract that 1.50 from 15. And I get 13.50, or 13.50. Notice here that I'm showing my answers to two decimal places because I'm talking about dollars, and we typically represent dollars down to the penny. So if the price was originally $15 and I got 10% off, my new final price is 13.50. Now I have the option of finding that I'm going to pay 90% and multiplying that by the 15. And when I did that, I got the same answer of $13.50. So it doesn't matter which of these two options you use, it'll yield the same answer. Let's take a look at this for the second and third example. In the second one, a 40% discount on $6 equates to subtracting $2.40 from $6, and that yields for me a total price of $3.60. And on the third example, a 22% discount on $878 equates to subtracting $193.16 from our $878 price tag. When I subtract, I get a final result that the price after discount will be $684.84. Now let's check those against when we found the percentage paid and multiplied. In our second example, if we got 40% off, that means we'd pay 60% of the purchase price. If we multiply that by the purchase price of $6, we yield a final price of $3.60. That's the same thing we found using our other option. In the third one, we find that if we're getting 22% off of the price, we're only going to pay 78%, or in decimal form, 0.78. We multiplied that by the original price of $878, and we found that our new price after discount is $684.84. Again, this is the same as what we found using our find the discount and subtract version. So it's up to you which of these two you prefer to use. I prefer the second version, where we find the percentage we're going to pay and then multiply that by the purchase price, because it tends to be a little faster. Markups are another way that percents get used. A markup is an increase in cost that is added to find the price at which we want to sell an item. So let's say that we have a business where we make t-shirts, and each t-shirt we make costs us $10 to make. If we sold that shirt for $10, we'd break even. We wouldn't make any money and we wouldn't lose any money. If we sold it for less than 10, we would lose money. And if we sold it for more than 10, we would make money. Let's come up with a percentage we want to mark up or increase the price over the cost. So we need to charge at least 100% of what the item costs to break even. Our markup is how much more than that we want to make. So let's say I want to make a 50% markup. That means that my new price needs to be 100% of the old price plus 50% of the old price. That means that I want to charge 150% of my cost in order to get a 50% markup on the item. Once we have the pieces set, we can use the steps we had before. Let's find out what the price will be if the cost was $10 and we want to get 150% of that cost as the price, that is equivalent to a markup of 50%. Those same two steps come back. We're first going to convert the percent to decimal form, then we're going to multiply that decimal number by the cost. The decimal version of 150% is 1.5. I have a cost of $10. I need to multiply that by my decimal of 1.5, and when I do that, I get a result that the price should be $15 if I want to get all of my costs back plus a 50% markup. Before we move on, let's do a quick double check to make sure the answer we got of $15 makes sense. If I spent $10, that's 100% of the cost. I wanted to add 50%, which is half of $10. So I wanted to add 1/2 of $10 to get my markup. That would be $10, my original price, plus 1/2 of $10 is $5. So yeah, my answer should be $15. Things are checking out. Pause here and try to solve for the following. Let's say our cost is $26 and we want our price to be at a 100% markup. And let's say we have another item that has a cost of $340 and we want our price to be at a 75% markup. For the first example, we want to recoup 100% of our cost, plus we want to make another 100% of our cost as a markup. So we, as a total, want 200% of the cost to be the new purchase price. When I convert 200% to a decimal, I get 2.00. I now need to multiply that by the cost, which was $26, to get my new price after markup. 2.00 times $26 is equal to $52. So my new price with a 100% markup over cost is $52 for the item. Let's try the same for the third example. I want to recoup 100% of my cost, plus I want a 75% markup. So I want to get 175% of the original cost for my new price after markup. If I convert this to a percent, I get 1.75. Then I'll multiply that by the original price of $340 to get my new price with the markup. Therefore, my new price after markup is $595. Let's take a look at these last two answers and make sure they are checking out. That means that they make sense before we move on. In our example of wanting $26 with a 100% markup, what we're saying is we want to be doubling the cost and setting that as our purchase price. When we double the cost of $26, we got that purchase price of $52. And this makes sense logically. If the item costs me $26 and I charge $58, I'm taking more money in than I'm spending on the item. So this is good business practice. For this last one, Our original price is $340. Our new price is $595. We wanted to nearly double the cost when we set our purchase price, so we set it at 75% more. Had we doubled our cost, that is, had a 100% markup, it would have been $680. So we know it should be high, but lower than $680. And it is. We got a price set with a 75% markup of $595. So this looks pretty good. It's less than double, but it's close to double, which is what we'd expect here. Okay? So in this last example, the cost of $340 is lower than what we're charging for the item, so everything checks out and makes good sense. Now for the final big one, putting all the pieces together. Suppose there's a shirt you like that costs $17 to make, and the store which sells it charges a 250% markup. Find the price they would charge for the shirt. The original cost is $17. The multiple that they're charging is 3.50 because they want to recoup 100% of the cost plus an additional 250% as a markup. So that means they're going to charge 350% of the original cost to get the price. I translate this into the decimal form of 3.50. That's how I know I have a 3.5 multiple. When I calculate this out, I get that the price will be $59.50 at this store. Now, what if this store that's charging $59.50 for this shirt realizes they have too many and they're not selling fast enough, so they put them on sale for 35% off? What would be my purchase price for this shirt if I got it during the 35% off discount sale? That means I'm getting 35% off, which in decimal form is 0.35. Or I'm paying 65% of the price, or 0.65 in decimal form. I can multiply these by the price to find how much will be discounted or how much I'll be paying. If I look at how much I'll be paying, that's going to be 65% of $59.50, or 0.65 times 59.50. In that case, my purchase price is $38.675. If I round it to the penny, it's $38.68. Now let's look at if I find my percentage off. 35% off means I'm getting 0.35 times the purchase price, or the regular price of $59.50, off. That's a discount of reducing $20 and 0.825 cents. If I round that, that's $20.83. When I subtract $20.83 from $59.50, I find that the final purchase price after my discount is going to be $38.67. This is nearly identical to the answer I found when I did 65% of the total. I'm off by 1 penny due to rounding error because we had that 0.5 at the end of each of these. So we're approximately yielding the same result here. We're going to pay about $38.68 for this shirt after discount. If you'd like some additional review and practice, you can pause here and try the 3 tables of questions. Then move on to the end of the video to see the answers. The first table in green asks you to convert from decimals to percents or percents to decimals, depending on which is shown. The second one gives you a percentage discount and an original cost. You need to find the new price after the discount. And the third one gives you an original cost plus the percentage of markup that's desired, and you need to find the final price. Remember, when we mark something up, we want to also recoup 100% of the original cost. So after a markup, your final price should always be higher than the original cost. You can pause here to check your work. The answers are in gold, and any answers that are dollar amounts have been rounded to the nearest penny.